ముందుగా ప్రియమైన విద్యార్థులకు మరియు వారి తల్లిదండ్రులకు నమస్కారం. నా పేరు కె వెంకన్న జూనియర్ కాలేజ్ చైర్మన్. నేను ఈ రోజు 10th క్లాస్ విద్యార్థులను దృష్టిలో పెట్టుకొని మాట్లాడడం జరుగుతుంది. అది ఏమిటనగా, మనందరికీ తెలుసు, గత 2 సంవత్సరాలుగా కరోనా కారణంగా విద్యార్థులు ఎటువంటి పరీక్షలు రాయకుండానే పై తరగతులు పంపడం జరుగుతుంది. ఫలితంగా ఐఐటి జేఈ మరియు నీట్ లాంటి జాతీయ స్థాయి పరీక్షలను సాధించడం కష్టతరం అవుతుంది. దీనిని అధిగమించడానికి మరియు 10వ తరగతి పరీక్షలో అత్యధిక మార్కులు సాధించడానికి నేను మీ ముందుకు కె వెంకన్న జూనియర్ కాలేజ్ ప్లాట్ఫామ్ ద్వారా అనుభవజ్ఞులైన అధ్యాపకులచే ఉచిత వీడియో క్లాసులు, హ్యాండ్ రిటన్ నోట్స్ మరియు గత ప్రశ్నపత్రాల సమాధానాల విశ్లేషణ ఇవ్వబడును. కాబట్టి నేను విద్యార్థులకు చెప్పదలుచుకున్నది ఏంటంటే, ఈ ఉచిత వీడియో క్లాసులను మరియు హ్యాండ్ రిటన్ నోట్స్లను క్లాస్ రూమ్ లో కూర్చొని చదువుకున్నంత సీరియస్ చదువుకోవాలను. ఇంకొకటి ఏమిటనగా, ఈ యొక్క క్లాసులు విన్న వెంటనే అర్థం చేసుకొని ప్రాక్టీస్ చేయవలను. ప్రాక్టీస్ చేయడం అంటే కేవలం చదవడం కాదు, పేపర్ మీద రాయవలను. అలాగైతే గుర్తుండిపోతుంది. దీంతో పాటు మీ యొక్క నాలెడ్జ్ ని పరీక్షించుకున్న కొరకు త్వరలో ప్రీ ఫైనల్ పరీక్షలు కూడా నిర్వహించబడు. ఈ యొక్క అవకాశాన్ని సద్వినియోగం చేసుకోవాలని 10th చదివే విద్యార్థులకు విజ్ఞప్తి చేస్తున్నాను.
Yes, welcome back students. I am Yogananda here, teaching class 10 mathematics. We are going to start a new topic called mensuration. It is a new chapter. The name is mensuration. What is this chapter? What is this chapter all about? Let me briefly introduce this chapter. You need to recollect what you learned in the class, in your previous classes, class 8 and class 9. There are some geometric figures, 2-dimensional geometric figures, 3-dimensional geometric figures. 3-dimensional figures means what? What kind of figures are they? Suppose we take a box like this. It's a carton. It's a carton box. It is, the area of cross section is rectangular. It has got its own height, and now it is a 3-dimensional figure. You take anything like that, whatsoever it may be. You take a chalk, piece of chalk. It is in a cylindrical shape. All these shapes, 3-dimensional shapes, are called solids. Solids, regular solids or solids. Solids are, we can say, 3-dimensional objects. Whatever it may be, you can call them like that. Any 2-dimensional figure, if it is seen in 3 dimensions with certain another component like height, width, length and breadth, this kind of additional thing which will say that, which will establish that the object is occupied in 3 dimensions, is a solid. So for example, I will take a square. Take a small figure like this. It is a square. What do you mean by a square? It has got 4 sides. All the 4 sides are equal. Am I right? All the 4 sides are equal, and the angle between any 2 sides is 90 degrees. The lengths are equal. It is a square. If the lengths are unequal, say for example only opposite sides are equal and the angle between the adjacent sides is always 90 degrees, then it is a rectangle. You know all this kind of figures. This is a rectangle. You know this figure is a circle. It has got a central point which is center and the radius, and it is rectangle and it is square. All these figures are 2-dimensional figures. So many figures are there, but now in our chapter in class 10 we are going to deal with 3-dimensional objects, not 2-dimensional geometrical objects, but 3-dimensional objects having got 3 dimensions. How to establish a 3-dimension object? I am trying to draw one figure here. Just look at this. A square is taken on the floor, and with a certain height we have constructed a room like this. It is a room. You can see that this is a three-dimensional object. You can see that. Or else wherever you are sitting, whatsoever room you are learning, this is considered to be a three-dimensional shape, solid. It's an empty three-dimensional object wherein you are sitting and learning. This is a room. A room has a length, breadth and height. In between this there are four walls constructed, and the two top and the bottom are constructed. Bottom is considered to be floor, top is considered to be the ceiling, and the side walls, four walls. In between the four walls on the floor there is a ceiling. In between these six rectangular dimensions, in two dimensions, there is a room located. It is an empty room. The room having got 50 benches, 60 students. All this is, or this room is a solid. Solid means if it is fully occupied, just like a chalk box. 100 chalks are inside a carton. The carton base is a rectangle. Sides are rectangles. Four sides are rectangles. The top is also a rectangle. It is fully closed. Inside all chalks are lying. 100 chalks are kept in a chalk box. Therefore it is a solid figure whose cross section is a perfect rectangle. So in this chapter we are going to learn few things which are very, very useful in our day-to-day life. Let me talk about one such day-to-day life activity. Quantity of water inside a bottle. Now I am taking my water bottle here. So this is the water bottle. You know pretty well that it is a half-liter bottle. How much water is inside the bottle? 500 ml. Say if I cut it exactly here, this particular portion, the area of cross section is a circle, and the upper portion, if I cut it like this, it is also a circle, and the radius of this particular circle throughout this solid figure or three-dimensional figure is the same, exactly the same radius. It is called a cylinder, and it has got its own volume. The volume is nothing but the contents. What is the quantity of water inside the bottle? It is the day-to-day application wherein this chapter will let you know, or will let you learn how to find out the volume of a water bottle which is in a perfect cylindrical shape. This is one example in day-to-day life. Let me talk about one more example. Canvas needed for making a tent. What do you mean by tent? How to make a tent? A tent is made like this. Am I right? So a tent is made like this. Inside you can be accommodated. So when we go to camps, suppose when we go to forest areas, when we go to hill stations, mountaineering, there are no ready-made houses. So we have to make our own tent. In our functions, certain celebrations, we call the tent house people and ask them to arrange a tent. How to arrange a tent? What is the volume required? All these things will come under day-to-day life activities. Understood? This is what is one application. And one more application. Number of bags inside the lorry. Number of bags inside the lorry. A lorry means a rectangular cross-sectional surface on the bottom and on the top and four sides. Again, you consider that as a cuboid. We call it cuboid. And number of bags which can be accommodated in a lorry. That is a day-to-day life application. Gas filled in a cylinder. You must have seen a cylinder. Am I right? The cylinder is like this in shape. You must have seen that the cylindrical shape, and we will put the pipe here and use the burner. This is a cylindrical shape, cylindrical shaped gas cylinder. We call it a cylinder. How to assume or how to find the volume of this particular gas inside it? What is the gas content in it? What is the volume of the gas inside the cylinder? If the cylinder is emptied, we know that we'll book a new refill, and he'll come and exchange this empty refill with a new one, filled one, and he'll charge for the gas in it. That's what is going to be happening in our day-to-day life activities. But what is the shape here? It is a solid figure having got a bottom circle and here also a circle. Exactly, if it is drawn like this, it is a cylindrical shape. You can see this, it is a cylindrical shape. It is a solid figure having certain volume. The volume is measured, and the volume is nothing but the gas filled in a cylinder. Number of matchsticks that can be put in the match box. You take a small match box, you know that how to light a dhoop stick or something like that. It is in the same shape. We take a matchstick and burn it and light it and use that light to ignite a candle or deep or dhoop stick or something like that. How many matchsticks are there in the matchbox? All these activities, when you consider, they are considered to be the activities or exercises under the heading mensuration in solids. Solids are three-dimensional shapes. What are the solids? You can see in day-to-day life so many.
Hello friends, myself Sunil Kumar Badal. I have done my BTech from IIT Kanpur. Here at KVC I am chemistry faculty. So first of all, let me wish you all the best for your upcoming board examination. Here at KVC we are the team of IITians and ITians and doctor to help you achieve your dream. So what are you waiting for? Come and join us and fulfill your dream.
Solids. For example, you take a bat, hockey bat. You look at this J-like bat. It is a hockey stick-like thing. It is a solid. How to find the wood content in it? What is the upper surface area? How much is charged for painting that bat with white color? And afterwards, what is the canvas required to put on it? Like that, there are so many questions. You look at a shape like this. This is a circular shape. If you take a football, which is like this, which is a spherical ball, a football is in the shape of a spherical ball, or a throw ball in the shape of a spherical ball. How much gas is to be put in it so that we can play comfortably along with this ball? All these figures are considered to be the solid figures which are very, very useful in our mensuration chapter. This is the introduction about that. Let me come to the chapter and let us do some exercise problems later. First of all, you should know, if at all you take a square like this and a square on it, and having got all the three shapes, three sides the same, it is a cube. Am I right? So first one we are learning about CUBE, cube. It is cube. We call it cube, and you are familiar with the cube, playing with a cube. You know how to scramble the cube and put them all in a single color on one surface like that. First of all, let me draw what is a cube. To draw a cube, you need to draw a square first of all. Another square just below that or above that, and join all the four sides. It is a open cube, or you can call it a closed cube. If at all you consider this as one wall of it, one, this is second, this is third, this is fourth, this is fifth, this is sixth. There are 6 walls. I am just drawing it like this. This is one wall. This is another wall. This is the base. This is the base. This is the roof. Inside that 1, 2, 3, 4 walls. Top and bottom. Each one, you just look at the first one. First one is, say for example, it has got a side A units. Height is A units. Length is A units. Breadth is A units. Now you see this particular one, shape 1. First you take shape 1. It is a square having got A and A. This is shape 1. Am I right? You call it a wall 1. Similarly, you take the bottom. It is also a square having got side A units. Top, similar to that. 4 walls, that means what? You are taking 6 squares of the same side. A units, and you take this kind of 6 pieces. 6 pieces like this. And put them, fold them like this. You bring the first piece here. Put it to the bottom, and the second square you keep it here, third square you keep it here, fourth square you keep on the top, fifth one you keep in the right side, sixth one back side. You just construct a cube. If you arrange them close to each other, because every side is A units, on A units you can take another square and assemble here, join here, and see that a cube is formed with the help of 6 square pieces. So let us talk more about this particular cube. What is the base area of the cube? Base area. What is the base? Base is a square, am I right? What is the square area? A square. How many such bases or such squares are available in order to form a cube? 6. That means the total surface area of a cube having A units side is 6A square, because the base is A square, the top is A square, there are 4 walls, 4A square, total is 6A square. Suppose I want to find the volume of it. What is the volume? What is the content in it? Base area is A square and total surface area 6 times A square. Only, not total, excluding base and top, excluding that 4 walls surface area is 4A square. This excludes what? Excluding base and top. Suppose 4 walls area excluding the top. There is no top for the cube. Only base is there. It's like our water tank. In that case, what could be the area? It is 4 wall area including the bottom. It is 5A square. So there are certain factors with regard to cube, certain formulae which are very, very helpful for us. A cube is a shape, a 3-dimensional solid having cross section as a square with A units. So A units length, A units breadth, A units height is a cube. It is a solid figure. What is the base area? A square. What is the total surface area? 6A square. Now let us talk about the volume. Volume of this is base area into height. What is that? A square into A, which is A cube, cubic units. You must mention the volume always in cubic units. A cube units, A cubic units. So it is a solid figure called as cube. All of you draw this figure. These are all bases. First side, second side, third side, like this. 6 sides are there. 6. And base area is A square because base is cross sectional area. We call it cross-sectional area. Cross-sectional area. So when you take a cross-sectional area, it is a horizontal cut. Remember that it is horizontal. Cross-sectional area is a square area which is a square units. So you must consider a cube like this, and about the cube, these are the set of formulae. Say for example, you are asked to find what is the volume of a cube. Find the volume of a cube having base area 25 square centimeters. 25 square centimeter. This kind of question may be asked for 2 marks, or sometimes even a smaller question for 1 mark. How to answer it? What is given? The base area is given as 25 square units. Base is a square. What is the area of it? 25. What do you mean by side? What is the side? 5 centimeter. Therefore, volume is 5 cube, 5 into 5 into 5, which is 125 cubic units or cubic centimeter. This is the question based on cube. A small question can be set like this with the help of cube formula. Similarly, when we talk about solids, there are few more solids. Let me change this particular solid. This is taken to be A, this is A, this is A. Now, I don't want to take that all sides like that. I am going to change it as cuboid. In cuboid, what happens? It is the rectangular area of cross section. The area of cross section is a rectangle. Instead of this, I am taking a cross section, rectangular cross section like this. Look at this. It has also 4 sides, 4 walls, 2 top and bottom. Altogether there are 6 rectangles, but the dimensions are changed. What are the dimensions here? When you look at this, this is the length, this is breadth, this is height. So when you talk about a cuboid, so let me move it to the other side and draw a fresh figure, cuboid. Always, whenever you people are learning how to draw a figure, think this way, draw this way. 2 rectangles parallel to each other. Don't draw rectangles in a rough way, with the different directions, zigzag way. Exactly this. Then join this, you get a cube. It is a 3-dimensional figure. So if you just look at this way, it is a 3-dimensional figure which is called cube. This is a hollow cube. Hollow cube means what? Inside you can put some material. So like that. If it is filled with something, it is a full cube, filled cube or cuboid having total volume full with certain gas or chalks or bags, something like that. Whatever it may be, whatsoever application you want to make use of that. But what is the dimension of a cube? This is the length. What is length? It is represented by L. What is the breadth? B. What is the height? H. So a cuboid is particularly made up of 6 rectangles